So let's think about ratios and proportions. I want to bring up two examples that I was just thinking about over the last few days. One kind of example is about the Olympics that's going on, Paris 2024. And as of today, when I'm recording it, the U.S. has 87 Olympic medals, and Australia has 37 medals. And the question is, which total is more impressive? You might think, obviously, the U.S., 87. But I think not too much thought makes you think, well, that might not be a fair comparison. You might know that Australia, even though it has a lot of land area, it's not nearly as big as the US. And so there's various ways we could answer this question, but a fairly reasonable way is to bring in the populations and say the US population is 335 million. Australia is only 27 million people. That's a lot smaller. Immediately, I think we can see, at least qualitatively, that totally flips it. But we'd like to make that a little more quantitative, a little more careful, and say, I think we're maybe comparing, doing some sort of ratio comparison. So in other words, what we could do, and there are more sophisticated things you can do, I gotta admit, but this is a very good one to start. Just how many medals are we winning per million people in each country? And that's going to be a ratio, right? So the U.S., we're going to have 87 medals per 335 million people. Okay. And so I'm writing it as a fraction. We can think of that as a ratio, as a relationship between two numbers, or we can actually think about dividing 87 by 335 to get a specific number. That's a fairly subtle thing, that a ratio, a relationship between two numbers, really can be thought of as just a single number if you just evaluate it. So let's actually do that. And so I get just over 1/4, 0.2597. So about a quarter of a medal so far. We're not done with the Olympics yet. Per million people in the US. Okay. And then Australia, we've got 37 medals for only 27 million people. And I'll have it calculate that. Whoa, that is a much bigger number. 1.3704. Okay. Honestly, there's no point in having so much precision there. Okay. So Australia is getting over 1 medal per million people, well over, about 4/3, if you wanted to approximate that. This is a tiny bit over a quarter of a medal per million people for the US. So by taking a ratio, we're getting a very different kind of comparison. Instead of total medals, we're doing medals per population, and Australia is really kicking butt. It's really impressive. So we can get a little more sophisticated, but it's still in the same vein of like, well, we're just kind of doing the same kind of comparison. So for example, if this number just kind of doesn't mean much to you, and these ratios sometimes aren't incredibly intuitive, although sometimes they are, we could say if Australia had the population of the US, how many medals would we expect them to get? And so that's a good example of a proportion. So this is a ratio where you're comparing two numbers and essentially dividing them to make a fraction. A proportion, we're going to set up a proportion, and that is an equation of two ratios. You can look in the book for a little bit of terminology, but I'm not going to worry about it right here. I want to focus on some of the fun things we can do with them. And so what we can do is, this is going to be there's an unknown here, right? How many medals would we expect? So we're going to say, instead of saying the 37 that they actually did get, then we're going to say, okay, 87 medals for the US out of 335. What if nope, wait, that's not what I wanted to do. I got confused for a sec. Okay, so Australia had the population of the US and the same medal rate per person. So they're as amazing as they are in terms of medals, and we're going to scale up their population. And we want to know how many medals we're going to get. So we want to keep this 37 over 27. So that's the ratio that we know they are getting. Well, what if we said, what's the corresponding number of metals, let's call it X, that they would get if we boosted up their population to 335? Right? So we're saying, here's a metal number for a population as big as the US that would give a certain ratio, a certain number, fraction, that matches this really impressive fraction that the Australians actually get. Right? So this is a great example of a proportion. We've got two ratios that we're setting equal, and very often we have an unknown in one of the slots in one of those ratios, and we want to solve that equation. And almost always, to solve this guy, there's maybe a few special cases, we cross multiply. We're just going to multiply both sides by 27 and by 335. You don't usually want to write this out in this kind of detail that I'm doing right now. It's not a great idea once you've got the idea. But we're just doing what we always do to solve equations. We're doing exactly the same thing to both sides of the equation. And we're noting that these 27s, let me just copy this. We're noting that these 27s are going to cancel. That's why we're multiplying by the 27. So those go away. And the 335s over here cancel, so those go away. If I can get the cursor in the right place. And what we get is what we call the cross product property, that the product of this numerator and this denominator, these are sometimes called the extremes of the ratio, is equal to the product of this numerator and this denominator. This is sometimes called the means of the ratio. I never use that terminology pretty much. I just know that if you cross multiply, you get this. And then we can just do one more division. We can divide by the 27. So 335 times 37 over 27 equals X. And then we can do a numerical calculation. And, okay. Whoa, 459. And we're going to round it because it's supposed to be a prediction of a number of metals, and you can't really win 0.07 metals. But this is just a what if anyway. We're not saying this is some precise thing that's going to happen in real life. So that's pretty amazing. If the US was getting metals at the Australian metal rate and the size that the US has, we should have 459 metals compared to, remember, this 87, which seemed impressive at the start. Now it doesn't seem so impressive compared to Australia. Okay. Let's see. Let me do another video with a little bit of a twist on the same example of metals.